Good morning. This is Ms. Billerbeck, and we're going to talk about 14.4, the graphical method of solving quadratic equations. So our first equation is x squared plus x minus 4x. So y equals x squared plus x minus 4x. So let's get a table put together first. So we have x squared, that's a y equals, by the way, plus x minus 4. And now we're going to put in various values here to try to figure out what's going to be best for us. Okay, so we should put in a few values. We may need more values than that. Okay, so I want to start with 0 for x because it's easy. And remember, don't make it harder than it needs to be. So 0 squared is 0 plus 0 minus 4. So that's minus 4. So this happens to be my y-intercept. So it's an important point of interest when graphing a quadratic. Now let's try 1. So if I have 1 squared plus 1 minus 4, so that's 2 minus 4, so I have negative 2. Let's try 2. 2 squared is 4 plus 2 is 6 minus 4 is positive 2. And then 3, I have 3 squared is 9 plus 3 is 12 minus 4 is 8. So that's pretty high. So, well, we could probably still put it there. I usually don't go so high, but we'll do that. So I haven't seen any repeats yet. So let's go to negative 1. Negative 1 squared is 1. Minus 1 is 0 minus 4. Oh, look at that. We have a repeat. So that's kind of important. It's going to tell us that we're going to see something. We'll see negative 2 next if we use negative 2. That's what that repeat's telling me, that I have a line of symmetry right here. So I have negative 2 squared is 4, minus 2 is 2, minus 4 is negative 2, what I predicted. So that means I'm also going to predict a few other things, like at negative 3, I'm going to have 2. So 3 squared plus negative 3 is 9 minus 3 is 6. 6 minus 4 is 2. Okay, so I can see that there's going to be some symmetry happening here. So in fact, let me just put that in there. So at negative 3, I have 2. So this is plus x minus 4 right there. Okay, so we have some symmetry. So something's happening at negative 1/2. All right, so let's graph this. So we put a y here, an x here. We see our max is 8, so we can do 2, 4, 6, 8 right here. And we're only going to negative 4, and most of it's over here. So let's spread this out. Negative 1, negative 2, negative 3, and negative 4. Well, we'll go to negative 5 just to be thorough. And 1, 2, 3, 4, and 5. Okay, so I'm not going down below. Well, I guess I better go down below because look at that. I have some negatives here. So negative 2, negative 4. Okay, and let's just go to negative 6, negative 8. Okay, so I can't just pick and choose there. I need to go negative. All right, so my first point was 0, negative 4. So that's here. That's my y-intercept. Then I saw that I had negative 1, 4 here, and I predicted that there was some sort of line of symmetry going on right here. So why I put the numbers there is another story. So let's go ahead and move them over here. All right, and these numbers too, because they are going to get in our way. So 2, 4, 6, 8. Who do we appreciate? Okay, so that means I have a line of symmetry in here. Okay, so then I go to -2 and I see I'm at -2. That's right here. And -3, I am at +2. Okay, the thing about a line of symmetry is I'm going to note that I'm 3 away from there, so I should have a point right here. Okay, so that's an equal distance, 1, 2, 3, 1, 2, 3, or 1.5, 1.5. Here, so this point, 1, -2, boom, it's right there. And then I count 1, 2, or 1, 2.5, half, 1, 2. I should have a point here at 2, 2. Boom, I have that point. Now I have 3, 8. So at 3, I'm way up here at 8 in my table. I was really trying to not have the table in the way, but it is there in the way. All right, so I have 1, 2, 3.5. So a half, 1, 2, 3. So there I have it. So my parabola is got a vertex here, but I don't know what it is. Okay, but I do know that my vertex is going to happen right between -1 and 0. So that has to mean that my vertex is at -1/2. Okay, so what I'm going to do is I'm going to say y equals -1/2 squared plus 1/2. That's a -1/2, by the way, not just a regular 1/2. A -1/2 is right here, because that's 0. And then -4. So if y equals, that becomes a positive 1/4 plus -1/2, or let's just say -1/2. And let's convert that over. And then we have -4. So this becomes y equals, that's 2/4, -2/4. So I end up with -1/4 minus 4, which is just -4 and 1/4. So my point here was pretty close. It's just right there. So most of the action happens right around this, and this right here is called, that one right there is the vertex. And this one right here, whoops, I went right onto where I'm going to draw my curve. Okay, so let me redraw that, and I'll put the curve on there. It's called a parabola, by the way. So when we draw a parabola, we just kind of start from the vertex and then just aim up. Okay, and when you do this a lot, you'll get much better at how you draw these. Okay, so it just keeps going like that. Okay, so that's my vertex. We've seen that right here, this point here is my y-intercept. Okay, so this is the y-axis right here. That's my y-intercept. Okay, we have some interesting things happening here and here. Okay, if this is a y-intercept, what do you think those are? You'd be right if you said an x-intercept. So we have this thing called an x-intercept, otherwise called a root or a solution. So there's one right here, and there's one way over here. So those are our two x-intercepts or roots. Okay, and then we have our line of symmetry here. So that's how we would graph this equation, which is a parabola. Okay, we'll come back to this in a second, or when we finish, and we're going to apply the quadratic to this to figure out exactly what those roots are. But if we're going to actually approximate it, the roots are approximately at, that looks like -2 1/2, 0 is one of them. And that's a little bit beyond 1 1/2, so I'd probably say about 1 2/3, 0, something like that. But notice that the y is 0, the x has a value, and those are the y-intercepts, as opposed to this y-intercept that has an x of 0 and a y value of -4. Okay, let's look at the next example. Okay, so this one we are going to graph x squared plus 4x plus 4. So we make a little table, and we have y equals x squared plus 4x plus 4. We'll give ourselves a little more room here because the y-intercept's way up there. So let's make a bunch of these. Maybe we'll just make these smaller so we can have more data. How's that? Okay, so we put 0 here, and we know that the y-intercept's right here. Y-intercept. Okay, then -1. So -1 squared is 1, plus 4 times -1 is -4. So that's -3 plus 4 is 1. Okay, -2. So -2 squared is 4. 4 times -2 is -8. -8 plus 4 is -4. And then we have a 0. So that was wait. That was here. Okay. I'm like, what? I haven't done -3 yet. Okay. So let's do that again. So 4 plus -8 is -4 plus 4 is 0. -3, 9. And then 4 times -3 is -12. So that's -3 plus 4 is 1. We started a little bit too far over here. But that's okay. We can find out what it's going to look like on this side and use the line of symmetry. So let's use 1. So we have 1 in here is 1 plus 4 is 5 plus 4 is 9. Okay, so we see that that's pretty high up. Now let's just use the line of symmetry for that, because technically we have 5 points. That's a lot of points, and we can kind of imagine that this -4 should be at 4, and -5 should be at 9 if we follow this pattern correctly. Okay, so let's take a look. So I'm going up to 9, so let's do 2, 4, 6, 8, and 10 is up here. Then I have my line of symmetry is happening at -2, so I probably will be more, let's see, yeah, so -2. So I think I'm going to label over here, just to be a little smarter this time, and -4. We're not going to be going down because look how positive these y's are. Okay, so then here are spreads to 5. So we have -1, -2, -3, -4, and -5. So sizing your grid, your graph is an important technique when we're graphing, is how do you make the graph so it spreads your data out to the best size. So that takes a little practice. Okay, so at -2 we are at 0, and at -1 we are at 1. Okay, but we also see at -3 we are at 1, and we see at 0 we are at 4, and at 1 we're way up here at 9. Okay, so this is our axis of symmetry right here, because we see we have 2 repeats. So we have an axis of symmetry right here, which goes directly through the vertex. So this time we don't have to figure out what the vertex is. We could see it right here. So then if this is 1 away, and this is 1 away, and this one is 2, or 2 away, then we can move 1, 2 over here and have our other point here at 4, -4, which is what we predicted, or -4, 4. Okay, so this would be a distance of 2 here from the axis of symmetry. So this is a distance of 3, 1, 2, 3, then count 1, 2, 3, and we have a point there as well using the axis of symmetry. So that's how we graph very quickly using what we know. So the more tools we have in our toolbox, the faster we can do math. Okay, again, most of the interest is around this vertex. So we don't care about what's going on way out here because it's increasing rapidly. We may care about that depending on what real life situation it is. But right now, when we're graphing, we just want to see where this vertex is and then graph like that. Okay. So let's take a look at our points of interest. We have a vertex going through the line of symmetry, like it always does. And then we have a y-intercept, intercept, okay, and we have one root. So this is also the root, or x-intercept, okay, and there's only one. Isn't that interesting? Before we had 2 roots, this time we have 1 root. Okay, so that's how we would graph this using plugging in the data, looking for a repeat, which would indicate where the line of symmetry is going to happen, and then we draw from there. All right, let's look at this last example. All right, so on this one, we have x squared minus x plus 3. So let's again use this area here. I'm pretty sure this is going to be pretty far up. So we have x squared minus x plus 3. Make a quick little table like this. Okay, let's put, I'll put 0 here. So at 0, the x's cancel right here, and we have 3, which is our y-intercept. Okay, so now let's use -1. So -1 squared 1 minus a -1 is 2, because that's 1 plus 1. Plus 3 is 5. So it's growing pretty fast on that side. So let's try -2, and that might be all we do on that in the negative. So -2 negative 2 times negative 2 is 4, minus a negative 2 is 6. 6 plus 3 is 9. Yeah, so we'll stop there because we're going to go off page. So let's go to 1 for our positive integers. So 1 squared minus 1 is 0, plus 3 is 3. Well, look at that. We have a repeat. That means 1/2 is our vertex. So we may want to find that one. Okay, so 2 then is 2 squared is 4, minus 2 is 2, 2 plus 3 is 5. And then we see we have another repeat, and then 3. 3 squared is 9, minus 3 is 6. Wait, 9 minus 3 is 6, plus 3 is 9. Okay, so that's how it would look with all the repeats, okay, or the symmetry of it. So what we really want to see is, well, what's going on with 1/2? So that's the question that we will look into. Okay, so we have y and we have x. So let's start graphing. So we have 2, 4, 6, 8, and 10. And this time we can put this on this side because our symmetry is going to be on 1/2. So let's make this 1, 2, 3, 4, and 5. Okay, and then we have negative 1, negative 2, negative 3, negative 4, and negative 5. All right, so let's plot some of these. So we have 0, 3 is our y-intercept, negative 1, 5, right there, and negative 2, 9 goes right up here. Then on this side we have 1, 3, we have 2, 5, and 3, 9. So we really only had to do half of those once we identified the line of symmetry. So I'm just doing a little more work just so you can understand what you could do. Oops, I put the line of symmetry. Oh no, that's in the right spot because I made it so it would fall on a line. Okay, so we have our line of symmetry now. Got a little bit of a, there we go. All right. So let's find out what's happening at 1/2. Okay, so if I take y equals 1/2 squared minus 1/2 plus 3, and that should be, well, that is what we will find out, won't we? Okay, so that equals 1/4 minus, and then we're going to take 1/2 multiplied by 2 over 2 and add 3. So y equals 1/4 minus 2/4 plus, and you know, if we really want to, this looks like it's going to be negative, so we might want to do this, 3/4 over 4. So that gives me negative 1/4, because negative 1/4 minus 2/4, negative 1/4, plus 12/4. So y is then going to be 11/4, which is, that would give me 2 and 3/4. So at 2 and 3/4, oh, look at that. It was so close to 3. Okay, so then we have this coming down like this, making a gentle little curve here right at the vertex, and coming back up like that. Okay, so again we have the y-intercept, I'll just abbreviate that this time. We have a vertex, but what are we missing? We're missing a root. There's no intersection with the x-axis. So we have no real root, but we have an imaginary root, imaginary or not real roots. It's actually not going to be imaginary. It's probably going to be complex, but well, we'll just say not real roots do exist. Okay? But there are roots. So mathematicians sometimes just can't deal with no answer, so they make a way to find the answer. So that's why that quadratic formula is so important. So if we apply that, we have A equals 1 because there's really a 1 there. B equals -1 because there's really a 1 there. And C equals 3. So let's put that in the quadratic formula. X equals -1 plus or minus the square root of -1 squared minus 4 times 1 times 3. So 4 times A times C, all over 2A, which is 2 times 1. So then we have X equals, this becomes 1 plus or minus, and then in here is where it starts getting interesting. We have 1 minus 12 all over 2. Wow. Here we go. Fasten your seatbelts. We have -11 inside there. And remember, I worked so hard on that one problem not to have a negative in the square root. Okay, so what that is it's a problem. That's why we had to make a new counting system that wasn't real. So let's make some room. Pull up our sleeves and take a look. Okay, so we have something that when we deal with a square root, let me use a different color over here. So we have not real. So we have, when we have the square root of -1, we have created this letter I. Okay, for an imaginary number is the square root of -1. So what we can do when we come back here is we can say X equals 1 plus or minus the square root of -1 times the square root of 11 over 2, which gives us X equals 1 plus or minus I square root of 11 over 2. So those are our two roots, two imaginary roots or complex roots, because the complex numbers are a mix of a real number because 1/2 is very real. But then we have an imaginary component, so it becomes a complex number. So let's take a look at, well, if that's what that looks like when the parabola doesn't hit the x-axis, what does the quadratic formula look like when it hits the axis once? So let's take a look. All right, so we have A equals 1, B equals 4, and C equals 4 when we look at these numbers from here. So our quadratic then is -4 plus or minus the square root of 4 squared minus 4 times 1 times 4, all over 2 times A, which is 1. Okay, so we have X equals -4 plus or minus the square root of 16 minus 16 over 2. So this becomes -4 plus or minus 0 over 2, because the square root of 0 is just 0. So we get x equals -4 over 2, which is just -2. Well, isn't that what we found here, that this vertex occurred at -2, 0? And that's what we found using the quadratic. Okay, so that's how powerful this quadratic is. And then if we were to use it on this, the quadratic on this one, we would find that we would have a value between very close to these values when we applied the quadratic formula to this one as well. So if we have a equals 1, b equals 1, and c equals -4, and put it in here, so x equals -1 plus or minus the square root of 1 squared minus 4 times 1 times -4 all over 2 times 1, we get x equals -1 plus or minus the square root of 1 plus 16 over 2. Okay, so 1 plus 16 is so close to square root of 16, which is 4. So first let's write it out. -1 plus or minus the square root of 17 over 2. And let's approximate this like it was 16. So our first root would be -1 plus 4, because the square root of 16 is 4, over 2. So that'd be -3 over 2, which is -1 and 1/2. I must have done something a little off, huh? So let's take a look at what happened. So that's -3, okay, 4. And I graphed that right, so there's something wrong in here. So -1 minus 4 times 16. Don't see it. Well, let's move on. Oh, that's a +1 and 1/2. That's what I did wrong. Remember how I said it was pretty close to that, and that could just be the way that I drew it. So that's very close to that. All right, so we're okay. And then the next one is x equals, so we're approximates to -1 minus 4 over 2, which is -5 over 2, which is -2 and 1/2, which is what we picked up here. So again, the quadratic is really a powerful formula. So if you memorize this formula, I'll just write it in red because it's just that important. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. That is one important formula, the quadratic formula. All right, that's it for today. Have a wonderful day. Bye-bye.